Hey everyone, in this video we're going to be learning about systems of inequalities, and so we'll be graphing an inequality and then graphing a system of inequalities. So these are some examples of inequalities. Some of them have two variables, as you can see, with x and y. So let's start by graphing this linear inequality. 4x minus y is less than or equal to 2. And so the way we're going to graph it is you're actually going to just ignore the inequality symbol for a moment. While you're graphing, you're going to make it an equal sign. And then when we're done, we're going to consider the fact that it was an inequality symbol. So if we graph the line, if you want to solve this for y, you would have y equals 4x minus 2, and then you can plot that line using the y-intercept at -2, and then the slope of 4 over 1. And so that's a quick way to graph that line. Now, when you draw these lines, you do want to draw them a specific way depending on if your inequality symbol is strict or not. So these are considered not strict, and these two are considered strict. Strict meaning that something is strictly less than or greater than a value, and over here this is less than or equal to, or greater than or equal to. So what happens is when you have strict inequalities, less than or greater than, you draw a dashed line. That lets whoever looking at your graph know that it was strict inequalities. And so if it's not strict, you actually say that this is a solid line. And it's also because you can include all the values on the line. When you don't have the equal bar, you can't include the values on the line. So that's another reason why it's dashed. Alright, so what you do after that is you just take some numbers and you test them. So you plug in some points from your graph and you plug them into the inequality, and then you ask, is it true? Is it going to be, in this case, less than or equal to 2? And so for 3 of these points, this was true. These values were all less than or equal to 2. But these 2 points down here, these were not true. They were greater than 2. And so the 3 points that satisfied our inequality, we're going to keep those, and they're going to be part of the answer to the graph of this inequality. And so what you do is you consider what side of the line those points are on. And so all of the points that worked when we plugged them into our inequality, notice they're all on one side of the line. So if we have an inequality, the line is not just the answer, but so is the shaded part of one side of the line. So anything on the line, or in our case, like left to the line or above it. And so our final answer is actually this right here. So when you're graphing inequalities, you have to include the shading. The shading is part of the graph, a very important part, because without it, you would only have the line itself. And so we want any values that are satisfying this inequality, so less than or equal to 2. So anything on the left, I can pick any point I want over here, and it will satisfy this inequality. So that's why we need to make sure the shading is part of the answer. So here are some steps for graphing an inequality. Step 1, replace your inequality symbol with an equal sign. Then before you draw your line, you want to make sure that you're looking at your inequality symbol. If it's strict, meaning it's less than or greater than with no equal bar, you're going to use dashes. If it's not strict, meaning that you can equal the values, it has the equal bar underneath, then you use solid lines. And so the graph would separate your x and y plane into 2 or sometimes more regions, which we'll see in another example. After you've drawn your graph, then you have to figure out where you're going to shade. So in each region, select a test point. And what you're going to do is you're going to plug in the point into your inequality. And if it satisfies the inequality, then all the points on that region also satisfy your inequality. So then you shade that region. If you happen to pick a point that doesn't satisfy the inequality, then no point in that region satisfies the inequality, so you shade the other side. Alright, so let's go ahead and graph this one. X squared plus y squared is less than or equal to 9. And so remember step 1, set this equal to 9. And so this is actually the graph of a circle. So in general, a circle has this equation, and the number on the right is the radius squared. So this is a circle centered at the origin. And so we have a circle centered at the origin with radius 3. And our inequality symbol is not strict, so it's going to be solid. So when we graph that, it's going to have a circle that's separating our xy plane into two regions, one on the inside of the circle and one on the outside of the circle. So inside the circle, we can go ahead and pick the origin, 0, 0. If you plug that into our inequality, that's going to work. It does satisfy that inequality. It's less than or equal to 9. If you want to check, now a number outside our circle would be something further than 3 away from the origin, because our radius was 3. And that one doesn't satisfy our inequality. So any points outside the circle we don't want. And so when we graph that, that's what it would look like. So you can plot your circle because we know that the center was at the origin and the radius was 3. So you can go ahead and plot like 4 points where it's 3. And then you just draw your circle to connect those points. And it's solid because we had a non-strict inequality symbol. And then we tested a point, we tested 4, 0, and that did not satisfy our inequality. And we tested 0, 0, which it did. So then we would shade the region where that point is included. Okay, let's graph these two. So A is x is greater than 2, B, y is less than or equal to 3x. So if we set this equal to 2, we have x equals 2, and that's going to be a vertical line. And we do have a strict greater than symbol, so that's why we're going to draw a dashed line. And then anything greater than 2 is going to satisfy this inequality. We can test a point, 0, 0, for example, and it doesn't satisfy this inequality. 0 is not greater than 2. But also, if you just think about it, x greater than 2 is all the numbers to the right of x, or larger than x. So we would shade to the right of our line. X is equal to 2 here, dashed, and so the inequality, the answer to that, or that graph, is all of this region here. And so our next one, y is less than or equal to 3x, change that to an equal sign, and then go ahead and graph that line. You can plot the y-intercept, 0, 0, and use the slope of 3 over 1 to plot that line. And it is solid because it was a greater than or less than or equal to symbol. And then if you think about this, if you test a point, you can see, for example, 2, 0 does satisfy the inequality. If you plug in a 2 for x and a 0 for y, then you would get that this is true. But also, if you think about what this would look like visually, y is less than this line, and so y values, your y-axis here, the y values are less than or equal to 3x, so it's the y values underneath, so it's this whole region. So that's sort of another way to think about that. Okay, so we're going to be graphing the system of inequalities. And so remember, for a system, you have to have the x's and y's that satisfy both equations. And so this is a little bit more involved than our last examples because we have to satisfy both of these inequalities at the same time. So first, do what we've been doing. Change your inequality symbols to equal signs and graph each of these as lines. And they both have the equal bar symbol, so they're going to both be solid lines. And then what we want to do is we want to pick some test points. And so we can use 0, 0. It's a nice one to plug in, and see if that satisfies either of our inequalities. It doesn't satisfy our first inequality, but it does satisfy the second one. And so what we want is the intersection of the shading for the two inequalities. So for our first inequality, we start by drawing this line, and when we picked a test point, 0, 0, it didn't satisfy our inequality, so we shade the other side of the line. So we shade over here because that test point didn't work. Then our second line is this one here. This was from our second inequality. And then when we tested 0, 0 into that inequality, it does satisfy it. So we want the side of the line that includes that test point. And then for the system, we want to put these together. So we want to graph both inequalities on the same coordinate plane, including their shading, and then that's the answer we're looking for. We are looking for this region right here that satisfies both inequalities where the shading overlaps. So this is the solution to the system. Okay, let's go ahead and try another one. So we're going to graph the system here. 2x plus y is greater than or equal to 1. 2x plus y is less than or equal to 2. And so with these two, set each one equal to their value. And so this is inequality 1, which is equation 1 right here. This is inequality 2, and this is equation 2. And then when you graph each one, notice that they're parallel. And hopefully you can tell from just this part, these are going to be parallel. And now if you consider their shading, let's see if you take a test point. If we want to pick, for example, 0, 0 again, because that's always nice to plug in. If you plug that into inequality 1, you're going to get 0 is greater than or equal to 1, which is false. So for the blue line, that point doesn't work. So that's why we shade the other side of inequality 1. And then for inequality number 2, if we plug in 0, 0, that's 0 is less than or equal to 2, which is true. So for that one, and let's change colors, for the pink line, we like the point 0, 0, so we shade on the side of the line that includes 0, 0. And so it's not a very big region visually, but where this shading overlaps is right in the middle here. So this is the solution, just this part right here. Okay, keep going. Let's graph these systems. So notice again for part A, our lines were going to be parallel. And so we have that inequality number 1, which is over here in blue. We want anything greater than or equal to 0 for that inequality. And if we test a point to the right of the line, it would work. We don't want to test 0, 0 in this case because the line actually goes through 0, 0. So anytime your line goes through a point, don't test that point, test something on the other side. So let's say we tested 2, 0 right here. And if we plug that in right here for 2 and 0 for y, we would get 8 is greater than or equal to 0. And so that's why we shade the right side of inequality 1, that line. And then if we went with inequality number 2 over here, then we can test a point. Like, we could pick 2, 0 again because it's not on that line. And if we plug that in, we're going to get 8 is greater than or equal to 4, which is also true. So we like the right side of that line as well. And so the overlapping that we want is where the shading meets or intersects. So all this region is the solution. And so we actually could have figured this out without the graph earlier, because if we put these two inequalities together, we're saying that this expression has to be greater than or equal to 0. But then on the next one, we're saying the same expression has to be greater than or equal to 4. So this system together is the same as this single inequality. So this inequality would be the only one we would need to focus on for this particular system. All right, how about this part B? We had, again, 2 parallel lines. And when we graph them, so that's inequality 1 here, inequality 2 here, they don't actually meet at all. And you can test a point, so 0, 0 is a nice option again. So if you plug in 0 here and here, you're going to get 0 is less than or equal to 1, which is true. So you would include that for the blue. And then if you tested 0, 0 for the second one, you're going to get 0 is greater than or equal to 2, which is false. So you would shade on the other side of that line. And so there's no overlapping in the shading. And so there's actually no solution for this system. Next example, so we're going to graph the region below the line y equals negative x squared plus 4 and above the line x minus y equals negative 2 by graphing this system. And that's because below y is less than or equal to that line, and for above x minus y is greater than or equal to negative 2. So below is less than or equal to, and above is greater than or equal to. And then we'll label all the points of intersection. All right, so for the first one, when we change it to an equal sign, we have this blue parabola here. And so the vertex is at 0, 4. It's opening downward. And we have our x-intercepts at negative 2 and 2. Okay. And so our inequality was y is less than or equal to that parabola. And so that's why we end up shading underneath it or below it. And you can always test the point, like we've been doing. You could test 0, 0. And if you plug that in here and here, you're going to get 0 is less than or equal to 4, which is true. And then the second one here, our inequality was x minus y is greater than or equal to negative 2. And so for that one, we have our line and we want to shade above it. And so if we test a point for that one, you can say, again, let me just pick another point. You don't always have to pick 0, 0, but it's always nice because it's easy to plug in. So let's just say I pick 0, 1. So if I pick 0, 1, I have -1 is greater than or equal to -2, which is correct. And so notice where these overlap is right in here. So this is the region that would satisfy both inequalities. Now we want to go ahead and find the points of intersection, and so you can just do it visually, but it would be much better and more accurate most times to do it algebraically in case you didn't draw correctly, but we can kind of tell from the graph what we're going to get. We're going to get -2, 0 and 1, 3. And so if we have it as equal signs, we can just use either substitution or elimination to solve for when these equal. So we're going to go ahead and use substitution. Notice where we got that equation from. This was just y from equation 1 plugged into number 2. So this was equation 1 plugged into equation 2 where there was a y. And now you have one equation in terms of x's only, and we can solve that. So this is a quadratic equation if we rearrange it. And this one factors really nicely. So x is going to be -2 and x is going to be 1. And then we can plug those back into our equation for y. So y was -x squared plus 4. And so that's why we get 0. And then y was -x squared plus 4. And that's why we get 3. And so that's a way to find the points of intersection algebraically. Alright, just a couple more examples here. So graph this system. Notice we have 4 inequalities on this one, but 2 of them are really just saying the first quadrant. So when you have your coordinate system, this is broken into 4 pieces, and so if you didn't already know this, this is called quadrant 1, and then we go counterclockwise. So this is quadrant 2, quadrant 3, and this is quadrant 4. And so when x is greater than or equal to 0, that's on this side over here, and then when y is greater than or equal to 0, that's up here, and so that's why we're in quadrant 1, just because of these 2. So then we really just need to focus on these first inequalities. Alright, so if we concentrate on those first 2 inequalities, we have inequality number 1. If we rewrite that, that's going to look like y as an equation, y equals 2 minus 2x. And so that's going to be this line here, and it is solid because we have our equal bar here. And then inequality number 2, if we want to go ahead and rewrite that and solve for y, we have y equals 1/2 x minus 2. And that one is this one here. And so for inequality 1, we want to pick a test point, and let's go ahead and pick just 0, 0 for that one. And if we plug that in here and here, we're going to get 0 is greater than or equal to 2, which is false. So for inequality 1, we would shade to exclude that point. So we would be shading the top or right half. Then for inequality number 2, we can go ahead and pick 0, 0 again. So that would be 0 is less than or equal to 4, which is true. So for that second inequality, we want to include 0, 0. So far we can see the overlapping. It would be this whole region, but we also have the 2 inequalities that restrict us to quadrant 1. So we don't want this space underneath this part or on the left of this part. So the part that we want is all of this region that satisfies all 4 of those inequalities. Okay, let's try one last example. So a retired couple can invest up to $35,000. So there's a specific couple coming to you as a financial advisor, and you recommend that they do some things with their money. You're telling them that they should place at least $20,000 into one investment called treasury bills, and this will get them back 2%. So that's the money they earn in interest on their investment. Then you're telling them to put at most $10,000 into another investment, which is called corporate bonds, and that would get them back 3% on their investment. So they want you to help them take their money and split it into 2 different investments, and then we have amounts that they would earn on those investments. So we're going to use X to denote the amount of money invested in treasury bills, so that's X, and then we're going to use Y to denote the amount invested in corporate bonds, so the two different investment types. And using those variables, we're going to write a system of linear inequalities that describes the possible amounts of each investment. Okay? And so assume X and Y are in the thousands of dollars, just so we don't have to put all the zeros on our values. And then we'll graph the system. Okay, so here is the system, and here's why this is what it is. Again, all of these are in terms of thousands, so we're leaving off all the extra zeros. First, 1 and 2 from our two different investments, the couple can invest $0 or more into each type of investment. And so that's why we have inequalities 1 and 2. They can't invest anything negative, and they can't invest nothing, so that's why it's equal to 0. And they can invest anything more than 0. So number 3 right here, we know that together they have $35,000 to work with. So they can put money into investment 1 plus investment 2, the treasury bills and the corporate bonds, and together the money that they put in each of those accounts, it can't be more than the money they have. So it can be $35,000 or less. So less than or equal to the total amount of money, $35,000, goes into the amount of money into the one investment and the amount of money into the other investment. And then number 4 here, our recommendation was that they invest at least $20,000 into treasury bills. So that's why it's greater than or equal to, because if somebody says to do at least something, then it's that number or more. So it could be equal to 20,000 or greater than. So that's what at least means. And then on number 5, we told them no more than 10,000 into the corporate bonds. And so no more than is less than or equal to, because if I want no more spent than 10,000, it can be 10,000 or less. So this is no more than or less than. Less than is another way to say that. So this is a system of 5 inequalities, and 1 and 2 are kind of default for just not investing negative amounts. And then if we graph all 5 of these, we have the following result. And so again, remember that when X is greater than or equal to 0 and Y greater than or equal to 0, those two together just restrict us to quadrant 1. So we technically just have those inequalities making us be in this region here. And then we have inequality 3, inequalities 4 and 5. And we wanted to be less than or equal to 35,000. So we shade underneath that line. Then we wanted to be greater than or equal to 20, so we shade to the right of that line. And then we wanted to be less than or equal to 10,000, so we shade underneath that line. I know it looks crazy, but notice where all of my shading overlapped. It overlapped right in here. Okay, so that's it. We learned all about graphing inequalities and systems of inequalities. Thanks for watching.